Здравствуйте, Sam. Good morning, very good morning. How are you? Today we will study about DC generator. Only DC generator here. In my previous video, I taught about AC generator. AC generator. Here only we will know about DC generator. Let's start. Before starting, you should have good confidence, confidence with you. No need to depress, no need to afraid. Nikagda vayus, nikagda vayus. Be confidence. Confidence में रहिए. Nothing. It is very simple. It is very simple. DC generator. DC generator very simple. And board point of view very important. Very important. Very important. Very important. Let's start. In my previous video, I taught AC generator, in which you seen what? There is a magnet, armature coil, slip ring, carbon brushes. Same here. Everything is same. Only little difference. What? Only we will take slit ring. Let's start by figure. This is magnet. This is a magnet having poles. If there is a magnet, definitely magnet having poles. One is north pole, another is south pole. Here north pole. If this is north pole, this is south pole. Then why we select magnet? Why we are taking here magnet? Someone ask. Please reply. Why you taken here magnet? What you will reply? It is very important. Magnet is selected here. I make figure here. Why? Because we need in this space, in this area, magnetic field. And who will provide magnetic field? Magnets always gives, or we can say provides magnetic field. That is why we are taking here magnet. Someone asks, oh, please explain why you are taking magnet. Then we should reply, what? Magnet gives magnetic field. Here we need magnetic field. That is why I am making figure magnet. Magnet having poles. One pole is north, another south. Next, if there is a magnetic field, why you need magnetic field? For which purpose? Always think. For which purpose you are taking? You are creating in this space, in this area, magnetic field. Because we want, what we want? If there is a armature, or we can say coil, armature coil, if inside coil, inside magnetic field, armature rotates, then there will be induced current. And we need induced current. That is why we are taking here magnet. Magnet will give magnetic field. Inside magnetic field, we will rotate armature coil like this. Then if there is a magnetic field, inside magnetic field, armature coil rotate like this, then there will be an induced current. And we want induced current. So here again I am repeating what? Why I selected magnet? Because magnet gives or provides magnetic field. Why you want magnetic field? Why? Because if there is a magnetic field, inside magnetic field a coil rotates, then there will be an induced current, and we want induced current. That is why we select here firstly magnet. Here see, this is north pole, this is south pole. The direction of magnetic field like this, like this. Magnet gives magnetic field. For two arrow, I am explaining. You can make many, but here for understanding only two. Next, magnet gives magnetic field. Okay. Further, we will take what? Coil, or you can say armature coil. Why you want to take armature coil? Make here figure. This is a armature coil. This is armature coil. Say here name A, B, C, D. I put the name this and A, this and B, this and C, this and D. Further, A, the end of A is connected with split ring. Be careful. Be careful. Remember one thing. What? In AC generator, I had been selected slip ring, but here I will select slit ring. Slit. Why slit? Why what? This is ring. Cut here like this. And now this is called slit rings. Slit rings. Slit. Slit. S-L-I-T. Slit. This is slit. Okay. Хорошо. Next. Here, the end A, this end A is connected with slit ring. Then you can make figure like this, slit ring. Make like this, cut like this. This is called slit ring. Slit ring. So here I am making like this. Very easy, very easy. Very easy. No need to afraid. Никогда боюсь. Это очень хорошо. Физика. See, I make like this. Further what? Further what? I will take brush. Means here carbon brush. This is carbon brush. And further I will connect this brush with galvanometer. Very easy, very simple. Be remember, no need to afraid. Very easy. Very easy. This is complete. In your examination, what will you do? First of all, you should write principle. What is its principle? DC generator. Its principle is same as AC generator. And what is next? Construction. This is construction. Without construction, you cannot gain more marks. That is why you should be aware what? Principle, construction. This is construction. And finally, I will explain about working. Very easy working. Very easy. So easy. Very easy. Let's start. How? See here. Someone asks, why you take magnet? We should reply, we want magnetic field. Then further another question, why you need magnetic field? Then we should reply, because in magnetic field we want to rotate armature coil, ABCD armature coil. Why you want to rotate? Because we need an induced current inside it. That is why. Okay, let's further start. See, think, make figure, ask yourself, why magnet? Magnet gives magnetic field. Okay, inside magnetic field, what is purpose? Why need magnetic field? Then we should reply, inside magnetic field, if some conductor or conductor rotates, then there will be an induced current by the law of Faraday law, or you can say electromagnetic induction. Its principle, electromagnetic induction. What is electromagnetic induction? Here is magnetic field. A coil rotate inside magnetic field. Inside coil, there will be an induced current. And we want induced current. So here we say mechanical energy converted into electrical energy. We need electrical energy. Okay. Magnet taken for magnetic field. This is magnetic field. This is magnetic field. Y coil we taken here? Because we want current inside it. Okay. Next, here one end of the coil connected with slit ring. This is called slit ring. This is called slit ring. This is slit ring. Okay. And this is carbon brush. This is carbon brush. Here you can say name. This is X. This is Y. Carbon brush. This is carbon brush. This is Y. Here this is slit ring and carbon brush. Both are in contact. Both are in contact. Why this carbon brush in this contact? Because current can pass. Current can pass. That is why we taken this carbon brush in contact with slit ring. Slit ring. Slit ring. Slit ring. Why? Someone ask. Very good question. Why this slit ring is contact with carbon brush? Please explain. Please explain. Then what you will reply? If someone asks, you make construction of DC generator. Okay, I agree with you. But further, please explain why this slit ring is contact with carbon brush X and here Y. Why? Then we should reply, if current will induced in this arm, then current will pass through X and go to Y2 like this. That is why current can pass. Current can pass. That is why slit ring and carbon brush both are in the contact to each other. Next. Okay. Now working. You understand about principle as like as AC generator. Construction, something different. What? Only here I am taking slit ring. This is slit ring. Only that's all. Working? Okay. Let's start working. See here. Someone asked, repeated. Someone asked, why you selected magnet? You should reply. Because magnet provides magnetic field. Further, someone asked, why? Why you need magnetic field? We should reply because inside magnetic field, a coil or you can say armature coil rotates. Why rotates? Because we need inside coil current, induced current. That is why. Very easy, very simple, my student. Very easy. No need to afraid. Never afraid. Next. See here. Working. What is working? Very easy. Only you should know about Fleming right hand rule. You should know very well. Now let's start. Working. This is arm BC, PC. One side of the coil, same story as like as AC generator. One side of the coil, we should connect turbine. Here this is turbine. Why you connected turbine? Very good question. Okay, you can ask. You have right to ask. Why you are connecting here turbine? Then we should reply what? If turbine will rotate, the coil will rotate. This is coil, this is turbine. If turbine will rotate, then coil will also rotate. The coil will also rotate. That is why one side of the coil here, I connected turbine. When turbine will rotate? Very good question. You are saying one side of the coil, turbine should be connected. One side of the coil, turbine should be connected. Okay, you connect, I agree. But further next, when turbine rotate, then we should reply, we should send steam, water or wind inside turbine. If you are sending steam, water, wind, the inner, suppose that premier, for example, we are sending steam, then energy of the steam go to turbine. If turbine get energy, then turbine will rotate. If turbine will rotate, then also this coil will rotate, and we want what? Coil should be rotate. So when coil will rotate? Very good question. Very good question. Someone asked, oh, you are teaching DC generator. Okay, I agree. Please explain when coil, when this will rotate, then we should reply, here connect turbine, here connect turbine. If turbine rotate, then coil will rotate like this. If this rotate, then also this coil rotate. Suppose that this is coil. Next, when turbine gets energy, from which source turbine is getting energy, we should reply, we are sending steam inside turbine. Turbine gets energy of steam and rotates. Okay, this is, someone asked, oh, why are you connecting here turbine? We should reply, if we will connect here turbine and turbine gets energy from steam or air or wind or water, in that case turbine will rotate. If turbine will rotate, this coil ABCD will also rotate. Tarashu, Ladana, Ponial, Pinila. Okay, next. What I taught here, magnetic fields provide coil. Here why we taken coil? Because coil rotates inside magnetic field. Then we will get an induced current. Why you connected here carbon brush to slit ring? Because if they will be in the contact to each other, then current will pass. That is why. Why you connected here turbine? Why you connected here turbine? Because we need rotation. If turbine rotate, coil will also rotate, and we want coil should be rotate. If coil will rotate, then inside coil we will get what? An induced current, and we want induced current finally. Okay. Next. Okay, let's start. This turbine connected, turbine rotate. Suppose that turbine, this is turbine rotates like this, anti-clockwise, like this. This is anti-clockwise. See here arrow. This is our clock. Then our needle like this, just opposite direction. Anti-clockwise. This is anti-clockwise, means our here the turbine rotates in anti-clockwise. If coil rotates anti-clockwise, make here like this. Now next, then what happened? See, this is AB, this is CD, this is AB, this is CD, AB, CD, AB, CD. Okay. Anti-clockwise, rotate this anti-clockwise like this. Anti-clockwise. Then AB, this is AB, this is AB, this is AB. AB go inside. See here. Anti-clockwise. Okay, like this. Anti-clockwise. Then AB go inside like this. If this is AB, this is CD. Anti-clockwise. Then AB inside, and CD outside. If AB inside, if this arm is inside, then apply. Then we should apply what? Fleming right hand rule. Apply here Fleming right hand rule. Then what you will get? Fleming right hand rule. See here, Fleming right hand rule. This is magnetic field. this thumb AB, Sichas. Now this is AB. AB what? The arm AB. This is arm AB. Arm AB go inside. Then we should make like this. Inside. This is Fleming right hand rule. This is magnetic field. This is thumb, and thumb means arm AB. This is arm AB. AB go inside. Then inside. This is magnetic field. This is forefinger. See here, forefinger. This finger, magnetic field. The direction of magnetic field is in the same direction as our this forefinger. The direction of magnetic field is this. Then we should make like this. In Fleming right hand rule, this is magnetic field, and this is arm. Thumb means arm inside. This is magnetic field. This is inside. See here, central finger, downward. So an induced current, the direction of an induced current is what? Downward. Why downward? Because take Fleming right hand rule, apply Fleming right hand rule, make like this. This is in the direction of magnetic field. Thumb means the motion of conductor. Thumb means motion of conductor, motion of coil, motion of armature. Make like this. Then here, this is anti-clockwise rotation. That is why we should make like this. Then this is magnetic field. This is the conductor go inside. Here, this central finger downward. That is why I make here arrow downward. See here. Then this is the direction of an induced current. What is next? Current will pass through this slit ring, and slit to X to go to Y to this. Here we can put name R1, ring R1, and this is R2. R1, R2. What I say? One time more. Please explain. What I say? Here, turbine rotates anti-clockwise. In that case, this is coil. If anti-clockwise, this is arm AB, this is CD, AB inside, CD outside, AB inside, CD outside, AB inside, CD outside. If AB inside, in that case, our thumb should be like this, inside. And this is central, this is forefinger. Forefinger is in the direction of magnetic field, and this thumb is inside. Then the direction of induced current is what? Downward. That is why I make here arrow downward. This current pass through R1, further X, further Y, further R2, or further C to D. See here. Now a student should write in board examination. Very important. The direction of current is B to A. See here arm BA. The direction of current, this is current. The direction of current is B to A. Then we should write here BA. Further, current pass through slit ring R1. Ring means first letter R. R1. Here R1. Next. Then current pass through X. Further, go to Y. Further, R2. Further, DC. This is first half revolution. Keep remember. This is coil. A, B, C, D. Anti-clockwise, anti-clockwise, anti-clockwise. In that case, the direction of current is downward in the arm BA. Why downward? Because we apply Fleming right hand rule. Fleming right hand rule, we get like this. Then current B to A, further goes to R1, further goes to X, further pass to Y, or you can say goes to Y, pass to Y, further R2, further D to C. This a student should write like this, write like this. This is first half revolution, first half revolution, first half revolution, first half revolution. Next, this is AB, this is CD, anti-clockwise rotation. Then rotate like this and make like this. Means AB, AB here, AB. AB comes in the place of CD, CD comes in the place of AB. Then what happened? See here, AB rotate like this. No, AB anti-clockwise, anti-clockwise. Then this thumb AB go to in the place of CD and CD come in the place of AB. Again we should apply Fleming right hand rule. One time more. Video long but very easy concept, very easy concept, very easy concept. What I am explaining here, see here. This is first half revolution, okay. And next, see here. This is AB, this is CD. AB rotate anti-clockwise like this. AB comes in the place of CD, CD comes in the place of AB. What happened? Again we should apply Fleming right hand rule. How? See, this is AB, this is CD. AB comes in the place of CD and CD comes in the place of AB. We can make another figure, but no need here. Only here. AB comes in the place of CD. This is AB. The make right here like this. B goes to this and this come like this. D here, then come here. AB, this AB. AB comes in the place of CD. CD comes in the place of AB. In that case, in that condition, again we should apply Fleming right hand rule. Then what we will get? Again, the C here. If this CD comes in the place of AB, what happened? Again we should apply Fleming right hand rule. Fleming right hand rule. Then what we will get? See here. Here CD. Also this will come in the place of R1. If CD will comes in the place of AB and AB comes in the place of CD, then see here. One thing. AB is connected is R1. If AB comes in the place of CD, then R1 and R2 also change. This will come in the place of R2 will come in the place of R1 due to rotation. Okay. Then what happened? Again we should apply Fleming right hand rule. Here CD, see here CD, anti-clockwise rotation. Again like this, make like this, then we will get again the direction of current is downward. Again the current of induced current is downward. We should apply Fleming right hand rule. This is CD. Suppose that this is CD and CD rotation, CD anti-clockwise. Then CD arm go inside. This is central finger. This is four-finger magnetic field, and this is current. In the arm CD, the direction of current is what? Downward, like this. Then what should we write here? See here. This is CD. This is CD. Okay. The direction of current is CD. Further, CD goes to where? R2. Why R2? R1 comes in the place of R2 R2 comes in the place of R1. Then this is CD after half rotation. After half rotation, this is CD. The here R1 never. Here R2. This is CD. This CD is connected with R2. This CD is connected with R2. So here after half rotation, here CD is connected with R2. Now here will be R2. Here will be R1. CD is connected with R2. The direction of current is what? C to D. So I write here C to D. Further current pass where? R2. Further here X. Further current pass through Y. Further here R1. Very easy, so easy. R1 further go to here, not DC. After half rotation I am talking about this. Here what? AB. Here comes in the AB. A student should make like this. Should write like this. The see here, one time more. Rifting. If this turbine rotate anti-clockwise, or you can say anti-clockwise, coil rotates anti-clockwise. In that case, we should apply Fleming right hand rule, and we will see the direction of current is downward, always downward. In this portion, always downward, and in this portion, always upward, like this. Then see here, the direction of current always here, the direction of current X, here current pass through R2, R1, here X, here Y. So here what happened? X to Y. Again this rotate like this. Then again current pass through X to Y. In both condition, X to Y. In both condition, X to Y means the direction of current remain in one direction. Always in first condition, X to Y. See here, X to Y. In another condition, after half revolution, X to Y. See here, X to Y. The direction of current is X to Y. After half rotation, X to Y. X to Y means the direction of current is in one direction. The direction of current is means current flow in one direction. That is why we say DC, direct current. A current which never change its own direction, only remain in one direction. That is why we call DC current. That is why the word come DC generator. Why DC? Because first half revolution X to Y, next half revolution X to Y means the direction of current is X to Y means the direction of current is in one direction, only one direction. That is why we say DC generator. This is completed. The student. Again, final I am repeating. Someone asks, why you take magnet? We should reply, because we need magnetic field. Someone asks, why you need magnetic field? Because inside magnetic field, we need to rotate coil. Why you need to rotate coil? Because we need inside coil induced current. Okay, then this is the answer. Someone asks, why you this slit ring is contact with carbon brush X, and this is Y. Then we should reply what? So that current pass through. Current can pass through. That is why this is connected with X, this is connected with Y. And first half revolution, if this is rotating in anti-clockwise, first half revolution B to A, R1, X to A means current go to B to A, further R1, further X, further Y, further R2, further DC. After half rotation, what? CD. AB comes in the place of CD, CD comes in the place of AB. In that case, current flow C to D, further R2, further X, further Y, further R1, further A to B. Here A to B. This very simple. Students should write in copy, board examination copy, this and this, please. Next. Next what? Finish. It is DC generator. Very easy, very easy. First of all, purpose, why you select magnet, why you select coil, why you keep in contact with slit ring with carbon brush, why you apply Fleming right hand rule, because we want to know the direction of induced current. And like this is DC generator. Very easy. Thank you very much for watching video. We will meet another topic, home circuit. Further I will teach class 11 and 12 and up to higher class. Thank you very much. 10 विधानीय था चले दी इसी वीडियो